Hello, I'm glad you could join me today. In the last video, we talked about how programmers basically write source code. However, we did not talk about how source code is turned into a program that can be executed. That's what we're going to be talking about in this video. Now, between source code and program, there is one important step. However, that step has three different shapes or forms that it can appear in. The first one, the most classic one, would be compilation. Now, if we had C code, for example, that is written in the programming language C, you could put that code into a separate program that is called the compiler, which would take the source code and turn it into machine code. Now, why is this step necessary? See, source code is really just for us humans. We can read it, we can sort of understand it if we have experience in reading it. However, a computer will have no idea what stuff means in our source code. It will not be able to read it. However, machine code is natively understandable by the computer. However, we humans cannot read the machine code. That's why it's important to keep machine code and source code separated. And that compiler will take our source code, read through it, and see if it's correct or if it applies to the rules of the programming language that we're working with, and we'll turn that machine code, we'll turn that source code into machine code that is quickly readable by the computer. And that source code is compiled and usually then stored into a separate file, a compiled file. That file in turn can be linked into an executable. So if you have, for example, an icon on your desktop, that's an executable file. There's also a different way of doing that, however. There is this step called interpretation, which is used for languages that are interpreted. Interpreted programming languages, one, for example, would be Python. That is one of the most common ones. And interpreted is different from compiled in the meaning that you write your code, you've got your source code, and then you interpret it and it is run as is. By that I mean, if you really look at it, it's basically just real-time compilation. However, the machine code that is created in real time isn't stored somewhere separately as a file on your desktop example. It is instead just run as is immediately. Now, this has one huge advantage and one huge disadvantage. The advantage is that it's almost instant, especially for a programming beginner. You can just type your code, click a button, and it will run immediately, if it is correct indeed. If it isn't, then both with compiled and interpreted languages, you have to fix it yourself. However, with interpreted programming language, it's usually the case that they are much slower, because every single line in your program has to be read in real time, and sometimes many different times, which of course slows down the whole process. Now, that's not it though. There is a third way of running a program through source code, and it is sort of a mixture of compilation and interpretation. One very famous example would be Java. And if you've been with me since the last videos, you will know that Java is the programming language that I will be using for this tutorial. And Java does things differently. It is sort of semi-compiled and semi-interpreted. By that I mean, if you write source code in Java, you will then compile that code, but you will not have machine code that is completely readable by the computer instantly. No, you will have something that is called bytecode. Now, that bytecode isn't readable for you anymore, nor is it readable for the computer though. However, that bytecode, if then run through a separate program, your Java virtual machine or your Java runtime environment, it is then interpreted if you compare it to interpreted programming languages that are completely interpreted, Java is faster because it is sort of semi-compiled. So half the work is sort of done, but the other half has to be done over and over and over again. So it's still not faster than a compiled language. However, it is a fair trade-off, which has one advantage which might not be clear from the beginning, but however, when you take Java bytecode, it does not depend on what operating system you use or what processor basically you're using. It is universal. However, if you have a compiler, for example, for C, then you have to have the compiler specific to your operating system and your processor type. With Java, you don't have that problem. You only have to get specific when it comes to installing your Java runtime environment. So the first half of the process is universal. Now, I hope you understood what I meant by compilation, interpretation, and this semi-interpretation compilation thing that Java does. If you don't, feel free to watch this video again, and don't be afraid to ask questions. Sometimes we have to ask ourselves the most basic of things so that we can get 100% full understanding. Now, if you understood what I meant in this video, feel free to go to the next video where I will show you how to finally write your first Java program. It will be a Hello World program, and whatever you need to install on your computer, you will be guided through that process in the next video. That was it from me for this video. Goodbye.